So hi everybody, I'm a forecaster in Bergen, Norway. Today I'm going to present how we use nowcasting in weather warnings in Met Norway. So first an overview of the presentation. First I will start to show an overview of the different types of danger warnings at Met, and also an overview of the current nowcasting tools that we use. Then, depending on the time, I have two cases. So let's see if I have time for one or both of those weather cases where nowcasting was used. And in the end, some wishes for the future of nowcasting. So let's start with the danger warnings that we issue in Met Norway. There's a long list of them, but today the focus is going to be on rain, flood, and lightning, since they are the ones that we use nowcasting the most for these danger warnings. So I'll start to talk a bit about rain, flood, and our warning criteria for these warnings. You can see that our old criteria was a bit difficult to handle, and there was a bit we had the accumulation period that we had to distinguish between 1 and 3 hours. Also different criteria for city and countryside, and also different criteria for yellow and orange warning levels. Now we have made it a bit easier for ourselves this year with easier criteria, which is easier also for the public to handle. So 15 millimeters for 1 hour for yellow warning and 35 for orange warning. We currently don't have extreme forecast for rain flood, since we up north in Norway don't have such strong rain showers as other countries further south. And then on to the nowcasting tools that we use for rain flood forecasts. Of course, we use the radar. This is an internal site that we use, and we usually show it as an animation from 3 hours ago until present time. And it also includes thunder and this lightning strikes in this animation. We can also stop it and press forward one step at a time if we want. Other nowcasting tools. We have a nowcasting model which projects precipitation 90 minutes forward in time with a 5 minutes interval. So this only uses the radar precipitation. You can see that it doesn't generate any new showers. It only projects forward the precipitation directly from the radar. And we have a new nowcasting model as well. This I don't have so much experience with yet. It's quite recent that we got this in our system. But this projects the precipitations 9 hours forward in time with 1 hour interval, and it's also updated every hour. You can also see here that this one generates new showers. So this is not only based on the radar. And of course, we use observations. We have two ways of showing them. One is lists on a website internally, where we get hourly data and 24-hour accumulation period. And we can show them in our visualization tool, Diana, with 12-hour or 24-hour accumulation period, which is not so great for the rain flood. So then we mainly use this lists to get hourly data. But recently we are using private observations as well. The Net.mo weather map. These private stations has become quite popular in recent years, and so it's a quite dense market of these observations now, and these are much more densely situated than our official observations. So they're a great tool to use in Nowcasting, and also to check if our forecast was correct or not. So here I picked out a station in Sweden where you can see that we have hourly and daily accumulated precipitation. You can see that I had 7 in the last hour and 20 millimeters during the day. As for lightning, we also, of course, use observations, which you can see on the right here. Is our internal site, where we can set the time of accumulation of lightning strikes. So the max is 24 hours, and we can set it down to 30 minutes. And also the colors of the circles, they change colors depending on when the lightning struck. So if it's a recent one, it's more dark, I think, and if it's almost 24 hours ago, it's a more light color. We also use radar, of course, for the lightning strikes and other sites as Blitzachtung and so on. And we can also show them in our visualization tool, but there we have to count them individually. So no counting system there. And then we have a new product which is in the test phase. This uses max dBZ radar reflectivity. And when this value is more than 44, above a 2 to 3 kilometers height, it implies that lightning is likely to begin in 30 minutes. So what we can see here on the right, we have a yellow and a red square situated next to the radars. So the red one means that there was more than 44 max dBZ in this radar less than 15 minutes ago. So lightning is likely to happen in 15 to 30 minutes. And if there's a yellow square, like on the other radar here, the cell was from 15 to 30 minutes ago, so it means lightning is likely to happen in less than 15 minutes. And if there's a green square, it means that the cell was from more than 30 minutes ago, so lightning was probably already happened, or the forecast for this was wrong and it didn't happen. Yeah. But this is still in test phase, and I don't have much experience with this yet. But I'm trying to look at this throughout the summer and see how this behaves. And then on to a weather case. So I'll start with the weather case from last summer, end of July. And there was a weather situation where we had the high pressure over southern Norway for quite a few days. This was replaced with a low pressure system, which you can see north of the UK, with an occluded front, bringing in lots of moisture. And there was also some factors that was beneficial for rain flood, which We had a vertical wind shear and also high level trough, quite high dew point temperature and specific humidity, and the convective available potential energy values were also quite high in this situation. So the day before, we issued both a lightning warning and a rain flood warning. So you can here see the most probable areas are the darkest colors for heavy rain and for lightning. But we followed the situation closely, and looking here more at the Cape values on the bottom left, were quite high values, 15 to 1600, which is quite high in Norway. You can see that the scale ends on 1200, so quite high values, at least in northern Europe. And we also see on the top right the precipitation 1 hour values. And we see in some hours we had more than 30 to 35 from the MAPS weather model. So this could indicate that an orange warning was like on the limit to orange warning, so we had to follow this situation closely. Then looking at how we used the radar this day, there was quite a few areas with white in them, which means more than 43.5 set. Quite strong precipitation to be in Norway. And using the radar as well as observations, the forecast was upgraded to orange level in the southwest part of Norway. And looking also here at the hourly accumulated precipitation from the radar. On the left, it's from 12 to 15 UTC, and on the right from 17 to 20. There are quite a few areas with green or dark green, which starts at 20 millimeters per hour, 20 to 30. And there are also, if you can see, some small areas with red in them for several of the hours, which means 50 millimeters, which is quite a lot more than our criteria for orange level. And if we look at the observations, we had quite a few lightnings, 1500. It's quite a lot for such a small area in Norway in the summer. And also, if we look at the observations, our official ones had 27 at the most, but these are not so densely situated, so they often don't catch the highest rain showers. But looking at one of the private observations, we got one with 50.7 in 1 hour, and a couple more around that value. So it was a good decision to upgrade this warning. To summarize this case, the weather warning was upgraded to an orange level due to nowcasting with radar and observations. And the criteria was fulfilled for orange level by the NetAtmo stations. There were some damages to the due to the rain flood, but the heaviest rain luckily avoided the most densely populated areas. And then I think I have time for one more weather case. This is actually from 2 days ago when I was on the shift as a general forecaster. There was an occluded front bringing humid air masses and showers towards southern Norway. And it was decided to issue a yellow warning for lightning for eastern Norway, but it was decided not to issue for my areas, which is the mid and western parts. So I had to tell the afternoon shift to nowcast this situation and follow it up and issue a warning on a short notice if there was a lot of lightning strikes. And if we see afterwards what happened, we usually use this internal site as I mentioned before. You can see on the left all southern Norway, the lightning strikes, so around 300 lightning strikes on this situation. So for this large area, it's not, I wouldn't say it's a very bad situation. And also for western mid Norway, we can see in the middle and on the right, where we had 74 and 60 lightnings. So it was not grounds to send out the warning for west or mid Norway in this case. And summary of this case, there was not enough observed lightnings, as I said, to issue a danger warning. But this, the forecast has to follow the situation closely, and this takes a lot of time for the forecaster, which also has other duties and has to answer the media. And then in the afternoon, when the showers often happen, the meteorologist has responsibility for media in all of Norway. So it can also be quite a lot of phone calls on this shift. So automated suggestions for lightning danger warnings would be a great help. For example, this number is just from the top of my head, 200 lightnings in a given sized area as a threshold. And then this brings me on to my last slide. So what we would like to have in the future in Nowcasting, automatic suggestions for rainfall danger warnings. First, based on radar's reflectivities, calculated precipitation amount. Also based on the Nowcasting model's predicted precipitation amount. But observations could also be used. But the official ones are not so densely situated, so the danger warnings could also be based on private observations. There we could flag the obviously wrong observations. So if we have 3 observations close together, and one of them shows 50 millimeter, and the other 2 show 0, this will be flagged out as an obviously wrong observation, and we don't get the suggestion for a forecast. And also for lightning, automatic suggestions for lightning danger warnings based on observations, but they could also be based on radar reflectivity. If this test phase radar product turns out to be a good forecast for lightning strikes. And also for other warnings, we could use observations to suggest warnings, but these could also maybe be based on the Nowcasting model. And so that was my last slide. So if there are questions, I'm happy to answer.